Hello, I'm Mark Christian. Good evening. Welcome to Vision of Light Ministries. Today we have a special presentation from Dr. Prim, who works with NASA, and he has this presentation about the universe called Mysteries in the Universe. We also have our CEO of Vision Light Ministries, Duke Iqbal. So we will hand it off to Dr. Prim and go from there. Dr. Prim.
How are you doing, Duke, today?
Doing good. I have excited week, last couple weeks. I went to back home, just got back home 2 weeks ago. Then I went to Minneapolis, had a great time, meet great people. But we're going to talk about today about you.
That's wonderful.
You know, I know you've been doing great work. You've been teaching. So this is going to be very education type, you know, and good for your student, good for everybody. Because I have no idea for out there what they have, you know. So, please.
Well, a few years ago, you and I have been talking about the universe part, and that you are fascinated with some of the images I showed and the shared information about.
Yes.
And you inculcated this great idea that we should do a show. And
right.
We did not know that these years go by so fast, and we are here now.
Yes,
and I think, as we discussed during the past few weeks, I'm excited about sharing these wonderful mysteries in the universe, and particularly taking the information that we have now in 2020s. Probably 20 years ago, we did not have so much knowledge and information, even in terms of the images and other knowledge that we have.
Mm-hmm.
So, as part of my teaching, I use a lot of this material for my astronomy classes, and then other things that I do in space. And today I would like to start a new series under your direction through your VLF program. And Mark Christian introduced you very well, and then we are missing one more person, but we'd like to go to those discussions.
He'll be in, but it's your show. I'm just glad that I will be able to sponsor your show.
Thank you very much.
I wish I had the degree you had, the big old name degree. I don't have that one. So having to say that, let's see what you have for today.
Wonderful. I will start with a kind of overview of just looking into the sky tonight and the evening sky. I have this nice software.
Sure.
And anybody can work on this software. They can download to their cell phone, their computer, and they will be experts in astronomy to some level.
Okay.
At least we know a few things in the sky. We know where the sun is and how it's moving around. I will turn on my computer. If it is okay with you.
Yes, that's fine. Let's go see.
Adam, and then I would like to show my screen and talk from the screen.
Yes.
And what I will do is I'll walk onto this new podium that you built for me.
Go ahead.
Thank you very much. So this is definitely an honor and a privilege for me to talk about just the space that we see, the universe that we can imagine. And a few years ago, as I said, nobody could have seen such deep parts of the universe, but today we have some images. We're still a fraction or a fragment of information that we know, that we have to know. So on this screen, if you can look at along with me, on this computer, I'm going to maneuver that one. And this is the evening sky. We are in Houston, Texas, and now it is about time 5 o'clock in the evening, and 5:01, and the sun is yet to set. And I can actually look into this one and then move around the sky all around, and I have a particular object here called Venus, and actually you can see that one here. Very minute dot, and I'm going to focus into and see that one as well. But if you can wait a little bit longer in the evening, you have some more items in the evening sky coming up here for us, and I'm going to show them to you as well. And you're going to see all those beautiful things in the sky here as soon as we have the sunset coming up for our way. So just watch the sky, and I have this ability right now. What I can do is I'm going to bring my other parts of the screen here. This is my timer window where I can change timing. I can go forward now. Now all the objects in the visible sky, we have them here in real time. And we're going to change from 5 o'clock to, let us go to 1 hour, 6 o'clock in the evening. The sun is yet to set. So let us try to see that sun is going to set down today about 7 o'clock in the evening. We have a beautiful sky in the south part of that one. You see S is for the south here, and I have southwest and west part here. And we are in the month of October, November, December. Sun is not going to set exactly in the west, but about towards the western part of that one. Sun is going to start in the east and go all the way to the west. But in the winter months, it is going to be east, but it's going towards the south part and then set in the southwest of the sky.
Wow.
So that's the beauty of that one, because that's the area that we are going around the sun during those months, and that happens that way. Now about 7 o'clock in the evening, you have Venus here, very bright object in the western part of the sky. You can see that one. But if you can move around a little bit up here, you have Saturn and Jupiter. I'm a little bit cheating all of you because I'm giving the names right away. If I don't give the names, you will see what is this one. Okay, we have a bright sky there, bright object there, and so on. Let me see if I can turn off the names for you. So this is how you're going to see in the evening sky there. So somebody needs to tell you this is Saturn, and I can click on that one. It will give me the description here. Saturn is here, and the distance from Sun is about 9.933 AU. AU means astronomical unit. 1 astronomical unit is the distance between Sun to the Earth. That is 1 unit. And now we are talking about 9 times of that distance there from Sun, of course. Everything is based on the Sun. Earth will be here today, and 6 months now it will be on the other side, and then Saturn is trying to come over along. So we always measure from the Sun. It is 9 times. What is 1 AU? 1 astronomical unit is, in terms of miles, 93 million miles. 93 and 6 zeros. That is the miles. And we can never travel that far in our lifetime. At our speed of 100 miles an hour, we can never get there. But that is the 93 million miles, or 150 million kilometers there. So we're talking about that distance there. That is further away. And if I can move to Jupiter here, that is Jupiter that you're going to see in the evening sky. And its distance is also given here for us on this one. It is about 4.6 AU, about half the distance as if the Saturn is. Saturn is about 10 times distance from Sun right now, and Jupiter is about 5 times distance from Sun to Earth, if you can measure that way.
And this is all through a telescope?
This is all we can see through a telescope. Yeah, and I'll show you how it looks like through a telescope too. This software gives an that impression as well.
That's great.
So on this evening sky, Mark, as you are looking at, and we got other things too, the Starlink satellites and everything coming up there as well. And at any given time, we have about 22,000 satellites going around the Earth. And then if you are sitting in Houston, you will have about 14 to 1,600 satellites coming up and going down. We don't care for them, but they are very important for all your communication, cell phones, even the Facebook sometimes. Yes, it's all important for you to have all those things there, and we have those items there as well.
Is
So
that how the 5G come up?
A 5G comes up with these satellites being available. Yes, of course, yeah. And they're going to carry the data part for us. And then in the beginning, when we started with low G values, so to speak, so that we can use different satellites. Now we have a newer technology, newer satellites that are giving that.
And of course, I know the 5G is a lot faster as has been progressing this last year or whatever. But I know it's also dangerous.
It could be dangerous. Yes, it can have.
I didn't know what your take on that was.
Well, this is the same as like when we are having cars going at low speed, low impact, and low damage, almost no damage for human beings. Same car going at a high speed, could be a lot more damage there. The problem could be in the data errors, or the problem could be when somebody is trying to attack these systems. Is much more
The software.
easy.
Right.
Probably it can affect that way too. So that's why we need to be a little bit careful about that one. We're not too far from 6G, I believe, and then some testing is also going on those things as well. There. So we're getting fascinated with about 7.6 billion people around the world. Everybody needs to have at least 2 or 3 cell phones. That makes a lot more complicated for the data part as well. So. So back to the screen here, I have all these items there. We got Jupiter, and we got Saturn, and then we got Venus here. And Venus is going to be called as an evening star because we see most of these months in the evening sky. But if you wait a few more months, it will be early morning. It is called a morning star. It's an evening star and morning star for the same planet that we have. Before we know these are planets, people thought that they are all stars, bright stars. And they even call them wandering stars because it is appearing this part of the sky and then it looks almost the same in a different part of the sky, a different constellation, all those things. They call them wandering stars, and they became the planets later on. So we're talking about 15th, 16th century. Most of this scientific advancement in astronomy happened when Galileo Galilei and other people came on board, and they said, well, Earth is not the center, Sun is the center. We're going around the Sun. Things happened differently. People did not like that idea. People did not believe him. People actually ridiculed him, as well as he was excommunicated from the church, Catholic Church at the time. And later on in 1979, he was forgiven for that one, but he was dead by the time. So things can happen that way too. So let us look into these things here. Now we are still about 7 o'clock and 9 minutes right now. And I can take you a little bit more closer into Venus and see. Venus is on the other side for the Earth, very close to the Sun. So when we start with the Sun, we have Mercury, the first planet, Venus, the second planet, third is the Earth, and we have Mars. These 4 planets are known as the terrestrial planets because they have a solid structure on the top. People can stand, people can walk around. But when you go beyond that one, after Mars, you have this asteroid belt. A lot of asteroids are there, solid structure. Beyond asteroid, we got Jupiter. That's where we are right now. Jupiter is considered to be a gas giant, very, very big. Saturn is also a gas giant. It takes time for these spacecraft to land and go in and feel the solid structure inside. And we're going to talk about those things in the episodes to come as well for us. And then you got Uranus and Neptune, and Pluto. We almost dropped off from the list of the planets any longer for various reasons. We'll talk about that at a different time there.
Okay. So
So let us look at 3 planets. This evening sky, we have 3 of them there. And then Venus is at a distance of 0.68, about 0.7. If Earth is about 1 AU, Venus is much, much closer to Sun, about 0.7 AU there. So that's an interesting fact to remember. And Mercury is about 0.4 AU, very, very close to Sun going around there. So if you stand on the Earth, probably you will see Venus going in front of the Sun once in a while. Mercury going in front of the Sun once in a while. We'll talk about those things specifically because they have a pattern. They follow that pattern precisely. Sometimes it happens 100 years, sometimes it happens 24 years, and these things we'll talk about in a separate episode as well on the transits part there. Right now, let us go to Mercury and Venus here and see if we can see that one very, very close, up close. I'm just zooming in, I'm not doing anything here. You start seeing all kinds of other stars and other things there in the sky there. Now we got this one. We are very, very close now. And then we are going to look at Venus, if it looks, how it looks for a person who is looking through a telescope. That's how it's going to look. So now, if I put my telescope there, it is going to be very, very fast moving through. So I have a small area here where I can say I want to fix that one, so it won't move that fast here. So I can still go in and see. So Venus looks like this one. Do you see that hazy sub object there? And that is because of lot of these volcanic activity on Venus and lots of this gas dust there all around there. Venus also takes very, very long time to go on its axis. I'm going to show those things in my next part of the charts that I have for you and so on. So just keep that in mind. That is Venus. That's how it looks like through a telescope. It may not look in this color, but it looks black and white for us. Most of the telescopes will not have the opportunity to capture the color yet, but we have the other mechanism to have the color there as well. So let me go back here, and I'm going all the way back, and then I should be able to see when I come back here the other object in the sky. Now to the telescope, I'm tilted a little bit there, and now I'm going to take away the telescopic view for you. You can see that one. If I move a little bit here, I'm going to say this is Saturn, whether you believe it or not. That is Saturn there. And now I want to bring Saturn and see through the telescope how it looks like for us. What do you expect to see when we come very close to Saturn? All of you. I'm so glad that you're all silent now by this time. Okay. What do we see for Saturn there? This is one of the moons of the Saturn, and it is so close. When we put in the telescopic view here, you get that one, and it is going to be one of the moons there. That is called the Titan. one of the moons of the Saturn there.
Uh-huh.
So we are so far away from Saturn planet, but we have this moon there. People have seen this one, as ancient astronomers have seen that one. Do you notice anything happening to the Saturn here? What do you see now?
You get 3 more comes up on the top.
3 more moons are there. Maya, look at that one. What do you got there now?
Oh,
Now we got 4 of them there.
there's those rings.
You keep on counting, but there are about 66 known moons for Saturn there.
How many?
66.
Oh, wow.
And then I think people are still counting them, and they may be added as we go by. And recently we have seen very up close this particular planet, Saturn, through a spacecraft called Cassini Spacecraft. And this Cassini Spacecraft was launched by NASA and European Space Agency in 1997. It took 7 years to get there in 2004. And then of course it takes time because we got to travel 10 times the distance, 1 billion miles. We don't have enough fuel, so we got depending on other planetary bodies on the way along, and we got there.
Dr. Prem, what is that? You know, it looked like a different kind of structure, just like in a ringing and inside. Is that the hollow way, just the dark part? Or?
Amazing. That is a wonderful question that you asked me, and then I need to tell you the story about in the 16th century when Galileo Galilei was looking through this one, and he said that, well, there may be 3 objects, just like we said about this other moon there. And then finally he said that, no, these objects are not 3 different objects. It looks like a connection there. Imagine, there are no good telescopes in 16th century. Almost 50 years later, a student comes in by name Cassini, and he said, I want to get a PhD in astronomy. He said, well, whatever that Galileo was observing, I'm seeing the ring, and just like we have the question from Duke today, he said, that is a division. These rings are not connected. There is a separation there. And he called that one as a Cassini divide. That's what it is. If you can look at the up close on these rings here, you can actually see there is a gap, that one. Actually, the spacecraft that we sent, the Cassini spacecraft, we sent through that one so that we don't disturb these ring structure there. These are fascinating rings, and so many of them. In fact, we have one more division here, one more division inside. All those things came into existence later. Only in 1970s, the first spacecraft to take pictures of the ring structure is the Voyager up close, and that made into cover pictures all around. So we just finished the Apollo landing 1969, 70, 71, 72, and now we got this Voyager traveling and getting these pictures, an amazing thing. And we thought we are looking at the frontier of this astronomy through the NASA programs at that time, and we continue to do that way. And today we have other things looking at even Pluto and other things as well, Juno object, and so on. We are going to Jupiter and so on. So that is the division there, and there is nothing there you can actually travel through. When we send out spacecraft, it went through. It's mostly empty there. Remember, I said a lot more moons than 4 moons you have noticed. Some of the moons actually go in between these rings. They're always in the rings there. We have pictures of that one through this Cassini spacecraft recently, and it completed its mission after 7 years and so on. And we'll talk about that one in a different episode as well there. So let me bring you back here. Now you got an idea about Venus, closer to the sun side. And we went all the way 10 times away from us to the Saturn. We got the ring structure and other things there. And these ring structures slightly changes as the Saturn is going around the sun. It takes a long time to go around the sun. And then we are taking one every year, we are going around the sun. At times, it will be changing its orientation slightly, and this is the current orientation as of this year for us. And then if you wait for a few more years, you're going to change slightly there. So we'll remember that one now. We'll go back to the...
ask one thing.
Sure.
Okay, that Saturn is going around with Sun. So as is twisting, is the ring twisting the same time?
Ring will change its orientation slightly.
Okay, and then
it goes like this, and then
Okay.
comes back like this.
oh, okay.
So we can see the bottom part, but we got to live about 100 years to see the bottom and the top. But even people will see that one. It takes a long time to go around.
Interesting.
Very, very interesting, fascinating thing here. I'm going to show one last object here in this evening sky for us, and then now I'm going away in my telescope here. As you can see, you have one more object here on the left hand side. What is the name that I gave for that one, or what is the name I said before? Just want to make sure that you're all with me. That is Jupiter.
Jupiter.
So we started with Venus, and we looked at Saturn, and now we are looking at the Jupiter. Jupiter is almost in the evening sky. You can see tonight, and let me make sure that I can actually show you how it looks like in the evening sky here, and that we make sure this is the western part of the sky. This is the western part of the sky, and then if you can look through, you see this bright object Venus, and then you will see a faint object in the evening sky, and that is your Saturn, and a little bit more brighter object towards the left of that one is Jupiter there. That is the evening sky now. So let us bring Jupiter and see here. What do you think about Jupiter? Do we know anything about the Jupiter? Saturn, we know rings of the star. Saturn, ring structure is there. And Jupiter is known for its size. It's massive, the largest size that we can ever see of any planet that we know of. And we like this one for one simple reason, because it has about 70 moons. What are these moons? These moons are nothing but the asteroid belt. It is before the asteroid belt we have Mars. After the asteroid belt we have Jupiter there. Somebody told that it's a good thing that Jupiter is there. If Jupiter is not there, all these asteroid belts likely to come towards Mars, and if they miss the Mars, they'll come towards the Earth. If they come towards the Earth, we are not worried, but if our satellites are gone, everybody is worried their Facebook is not working. That's an important thing, right? So Jupiter works like a vacuum cleaner of the space. It keeps all those things away from us and is protecting us. So no wonder so many people at homes like vacuum cleaners. Like my family loves a vacuum cleaner. It should be there cleaning up everything there.
It's a lifesaver.
That is a lifesaver. It's a lifesaver for the universe, a lifesaver for the space.
Exactly.
And Jupiter is such a big one, gas giant. And we're going to talk about that one in a different episode here. It is about, if you take an Earth diameter and about 14 to 15 diameters of that one, that is the diameter of the Jupiter. But imagine the volume is going to be so much in terms of that one there. So that is the largest planet we are talking about. Let us go very quickly here. I want to show you one simple thing about this one, the fascinating thing. And people have observed this one. They call these moons in the 16th century, 1662 or so, these are the ancient moons. And these are called the classic moons. How many moons we have here for Jupiter?
You see 4 now.
You have 4 now, pretty close to 70 of them are there, but in this case only 4. These 4 moons were observed by ancient astronomers in the 16th century. And they gave names for these things. Those names are very easy to remember. I will give you the way: IEGC. I, 8 green carrots. R, I for Io, E for Europa, G for Ganymede, C for Callisto. They are all like that one. Io is very, very close to Jupiter. It goes about within 8 hours or so. And then we have Europa, and we have Ganymede, we have Callisto, so many of those things there. We'll just play a little bit of a time on these things here. I want to bring the names for you so that you all can be appreciating what I'm saying here right now. Those are the names that we have there. So right now we are about 7 o'clock in the evening here. And let me see what happens if I can move to 8:30 in the evening here. Do you see the moon there? What happened to the moon? It is behind that one.
Okay.
It takes a long time to come back.
Okay.
11 o'clock you come out. Look at that one. That's on the moon, and it's going so fast. So we're talking about 1, 2, 3, 4 hours behind. And then if you watch that one, it's going to be early morning right now. It's 6 o'clock in the evening there, bright light there. And then you can actually see, and then you can watch out that one. Now I'm going to lose this one because the 1 o'clock, 2 o'clock is going to be gone into the, it's going to set down. I mean, in the evening sky, nighttime sky, we don't see that one again.
So definitely more noticeable as it gets darker.
Exactly.
Right.
And then it becomes, now we can imagine that one. We are almost at the, okay. I made a mistake on that one. Okay, wait a minute. Okay, bring that one here. I'm going to go here, And I'm going to take away the telescope things here and see how fast it's going in front of our own eyes here. Now I'm going back here. Now it is about 12 o'clock in the midnight here, and I have all those things here. I can still see 12 o'clock. I can still see that one. Here is my horizon there, and I'm going to a little bit there. So see what happens here. 2 o'clock, 1 o'clock. I'm very, very close to horizon there, and after that one, 2 o'clock, it's gone. We can't see that one anymore from our vantage point in Houston, but some other country will see, and some other place will see. If you go to the other side of the world, they will start seeing in their early morning time here as well, and so on. So that's what is going to happen here. We can't see that one anymore. And so as you wait in the next few months, it'll be appearing very early in the evening. So you can probably have about 8 hours in the sky. We can actually see the moons going around that one. So that is the good news about this software here. And as I said, you can actually bring this software here. Now let me go back to the evening sky here. I got Venus back here about 7 o'clock time frame, and I will bring it to 6 o'clock, and you'll see if the sky is so bright, you may not be able to see other things here, except the fact that there is a Venus there is Jupiter there. And then let me put this one at about 7:30 in the evening. You will have all those things available for you to see that one as well. So that's what I wanted to give you a little bit of overview on these things here. Any questions for me before I show my next object here in the evening sky?
One more question.
Yes, please.
Is there any water that and the NASA or scientists found any of those planets?
Well, what we know about the water is Mars might have had water once upon a time because the land looks like a channelized water. What we have today on Mars are 2 ice caps on the north and the south. These ice caps are made of carbon dioxide, CO2. This is just like the dry ice that you can buy in Kroger's. I think we buy the dry ice and we ourselves ship that. You cannot touch that one. If you touch it, you will feel it. Right. And maybe your body remembers for a long time because it is so cold, minus 76 degrees. Yeah. Not just the ice about minus 4 degrees or 0 degrees there. And this is very, very cold. So it's good for shipping. We ship a lot of our cell samples with dry ice in the FedEx things, and it goes out. When it dries out, in case, it is going to be evaporated. There is no liquid there. So it's easy for transportation. So what we have on Mars, the north cap and the south cap are carbon dioxide things here. And we can actually see that one growing and decreasing over the time period because it's also going around the sun, further away from the sun and closer to the sun at times, and we have those things there. Okay? But we do not have any flow of water there as of now. Same thing on the moon. Moon is rotating, and I'm going to show you today, if possible, a slightly tilted axis, and that part of the bottom part of the moon, the south pole area, sun will never reach that one. It is always tilted away from the sun as it is rotating on its axis and coming around the earth, and then around the earth is going around the sun. That part is never going to see. But we believe the temperature is so low, maybe there could be water there. But on the surface of the moon, people have walked on that one, people got the soil samples back to earth, and we checked all those things. We do not have evidence of flowing of water, but the possibility of H2O, hydrogen oxygen, being there, possibility is there. So that's what we know as of now.
Okay, how about any kind of plant or any kind of life? Even not a human life, say creature type or insect or any kind of thing. Have they found anything? Or?
Well, on the Mars surface, we thought we might have had some microbes there, but it is not the soil from the Mars. It is a meteorite that appeared for us from Mars, arrived to the south pole of our own globe, our own Earth there. From there they found out, but it turns out to be probably it is not the Martian originated. We do not have any samples returned from Mars yet. We want to try that one. On the same note, I will say that we don't have any sample returned except our own moon from any of the planets to study what they have and how life could have sustained there. But recently, One of the asteroids, Hayabusa 2, is a spacecraft from Japan. It was launched in 2014. On the same spacecraft, they launched one of our payloads too from Japan. That spacecraft went to this particular asteroid and picked up a sample and returned back just this past December. It arrived, and when it arrived, we captured that one in Australia. And from Australia, it is moved to Japan. Now they are studying that one for the past a few months, that particular sample of that one. But we don't have any evidence of water being there. I can say so much about that water thing. It's an interesting thing there.
When you said they've been doing the sample, in those samples, has they found anything that match in our solar system, anything similar to any kind of match?
Well, very interesting question. We did not find anything new other than what we already know about that one. Even for the Mars in the 70s and the 80s and the 90s, we have rovers going all around and collecting data. Even now in 2020s, we have rovers there. And all that indicates that we have all those material on the Earth as well. In fact, if you can go to Hawaii volcano, one of the ash parts, if you can pick up that one, it is identical to Mars soil there, minus some material there, calcium, carbon, other things. So at NASA Johnson Space Center in Houston, we bring that soil from Hawaii volcano and add the missing part, and then we say that one is a simulated Martian soil. And we use that one for all kinds of experiments. If we want to send somebody, if we want to send Mark to Mars one day, maybe one way so far possible, and we want to make
happy
sure.
to go.
No Facebook there. He's happy to go there.
Hey,
But the
waiting list for
Hawaii-
one day.
The thing, I have it,
That's wonderful.
I got it when we was there, forgot what year it was, they just started the volcano, and the whole town, the Big Island,
It's completely covered with volcano.
it's gone. There was a church for 1800 and 1600 church. We went down there. This whole thing is gone. The rocks we saw. It was just mind-boggling.
It is mind-boggling. That itself is another episode for us. We can talk about the volcanic thing, activity happening in the ocean. You can actually see it coming out live. How can you quench the fire if the fire is in the water? That is a question there, but that is an amazing thing here. You're right. And it's covered with a lot of ash there, and that ash we collect and we utilize for scientific purposes there.
When you do that one, let me know, because
You want to bring your
I
soil?
got the video.
We'll do that one.
We have a whole thing captured on that happened.
We'll do that one. That'll be great. Let me show you last part of this evening sky, because tonight it takes a little bit longer time here, and I have a nice interesting thing about our own moon here, and I'm going to go to the eastern part of the sky here, and you don't have the moon there yet because it's only 7 o'clock according to my clock here on this software here. I'm going to change the time to 8 o'clock. You start seeing some of these green objects here. These green objects are nothing but activity of the meteor showers there. We can actually see them. And these are going to be like one every hour, one every 2 hours. So very rare. So you got to watch the sky for 1 hour without blinking your eyes, maybe, and then you will see some of them. But there will be some other activity coming up in December time frame. There will be more number of things happening in the sky. Actually, you can sit and you can watch all those things as well there. That's what they do in Wyoming and other places of the northern part of America. They sit down and watch these things happening there because of the beautiful sky and the clear sky as well there. So now it's about 8 o'clock in the evening. I can go to 9, 10, 11. You see this particular thing here? I have this beautiful structure here. And I'm going to talk about that one as well in a minute here. That is a constellation there. This constellation is called the Orion Constellation.
Orion, yeah.
And the Orion Constellation will have the Betelgeuse, the name popular, known all characters there, and Rigel star. And we're going to talk about that one very quickly as we move forward as well in my next part of the segment that I have planned for you. Now let us check on the moon here. 23, 11 o'clock, 11:30 now. Okay, about 12 o'clock, 12:30, you will start seeing the moon. You may not be able to see from your backyard yet because you got a lot more buildings and a lot more fences all around here, and you'll be able to see that one. That is the moon there, so we can see 1 o'clock. You're going to see the moon there. The moon. Let us check on the moon here very quickly, how big and how it looks like today. And this is the moon tonight for you. And I want to make sure that I have this one. Moon is, you look at this one, the distance part is given here, 0.994 AU, which is, Earth is 1 AU from the sun. Now, moon is 0.9 AU. It's a little bit closer to the sun on this side. It has to be on this side because the light from the sun should shine on part of the moon, which we will see from the Earth there. That is the beauty. If the moon is on the other side, you don't see that one because it gets a different part of the thing. We'll see that one in a minute here. It is only about 340 to 360,000 miles or kilometers, 260 kilometers from the Earth. We'll have a good explanation in the next slides I'm going to show you. Let us zoom in to see this moon part here. This moon, now you're looking at very, very close here, and you will believe this is the moon that you're going to see tonight. See, part of the moon. It's actually half a moon.
It's actually very
If you wait for 7 more days, you're going to have a new moon. And if you wait for another 14 days since then, you're going to have a full moon. November 19th is going to be a full moon, and November 19th is going to be an eclipse also, lunar eclipse.
So we can all turn into werewolves then.
We can get there. We can get there. That is a part of the story that we're coming across there. So this is the moon. We'll see a little bit of the moon here, so that you can actually see this is how it's going to look like in the telescope for us. And this is the part of the moon that you're going to see. Look at this, all these beautiful dents on the moon here. We call them beautiful dents here. This is called the near side of the moon. The moon that you see in the evening sky is always the same phase because it takes 28 days to rotate on its axis. Also takes 28 days to go around the Earth. So no matter what is happening to the Earth, you're always seeing at the same location. But if you stand on the moon, you're actually rotating on the moon there. It takes 28 days to come back. It's always the same. This is called the near side of the moon because it's closer to us.
What is that? Somebody look like a green. Is that those the crater or?
Oh, these are all the craters there. Yes,
Okay.
these are all the craters here, and you have a huge crater somewhere here, and you're going to see only this part of the moon right now. And every crater got a name. They have named these things long time ago before we were born, like in 16th, 17th century, because that's all they got to see. Now they developed these telescopes. They want to see the moon, and everybody got a name on that one, and we got all those things. Do you see some of these bright objects there? Those are the impacts from other parts of these asteroids hitting the moon there. Do you remember seeing the surface of the moon when Neil Armstrong had his first footprint? Even today it is there. If you go tomorrow, you will still see the same footprint as it is. Because it's all vacuum, no atmosphere there. We have atmosphere on the Earth. We can breathe. We can look at the sky is blue, everything good. On moon, no atmosphere at all. From Earth, when we look at these bright stars, they look like a twinkling star. Twinkle, twinkle, little star. We talk about that one.
Right.
It is not the stars are twinkling. Our atmosphere is moving back and forth. When these variations in the atmosphere are changing, when we look through our eyes, it looks like light is changing here.
So it's pretty much the motion of the rotation.
Exactly.
Of those
Earth is rotating, atmosphere is moving around. On the moon, when the people landed, Neil Armstrong and Buzz Aldrin, Apollo 11 in 1969, we asked them, can you look at the stars and see and tell how you feel that one? They looked at them. And then not only that one, Apollo 11 got one more astronaut, Colin Collins, going around the moon. He's waiting for these people to come back so that they all can come home. He's also looking at the stars. No blinking of these stars at all because there is no atmosphere there for them. That's why we know there is no atmosphere. What is there? It's called vacuum. In the vacuum, when you press a powder, it remains that shape. And that's what it is. On moon, so many other things are coming and hitting over and again, over and again, over and again. A small rock will become many pebbles, and many pebbles will become like a sand particle. Sand particles will become like a powdery dust over time period. Over the centuries, over the thousands of years, that's what is happening. We're thankful because if moon is not there, some of them can miss the moon and come towards us. And that's the end of the story for some of them. They will be huge and big too. So we are thankful for all these things that's protecting us in a way. And these things are, some of those things are going to have a live impacts are predicted as later part in December 4th time frame. If you have a telescope, you can watch the moon constantly this year. And some of these meteorites are going to be on towards the moon that we think about. And these things are asteroid parts that will come in and hit moon, and you can actually see the plume of that one from the Earth. We have some of those pictures, and some people actually study those things, and our own colleague is going to study those things as well with the special cameras and so on. It's a fascinating part of it.
You think so? You will be able to show us those pictures?
When we get that one, I will show in one of the episodes. Yes,
Good.
We'll have a separate episode on that one too.
Good.
Sure.
So I'm just giving you an appetite of all these things that we're going to talk about. And this is my moon here, and but not my moon, our moon, or your moon maybe. And then we
God's
can
moon.
go back and get that.
I thought that
Exactly.
would be his moon because we going to send him over there, right?
We're going to send him Mars one
Oh,
day.
Mars.
Well, I could go.
I'm
I could go to
sorry.
the
I
moon
tried.
as well.
I try, you know.
I could be that special Martian.
Talking about the landing on the moon after 1972, we've been thinking about sending people back to moon.
And I know it's been a very,
You know
very
what,
long time since.
People are fascinated, and we are ready to send the people to moon. And we selected some people who will be going on the spacecraft to the moon. And we also included a woman this time from the United States. Very good. And then some other countries, they are very specific to send women to moon first. And it can happen in our lifetime there. And we look forward for that.
Is that any chance, you know, I know scientists look at it a different way, looking for a second home or something like that. So you think so that one point that we will be people go on the moon and make that housing in there and stay in there?
Well, in 1970s, when we got this Life magazine, the famous one before the internet was there, and they had colonizing the moon, the entire magazine, and I happened to see that one. And we're talking about from 1970s going to the moon and colonizing all those things, but it's still a possibility there. But do you want to do that one? There may be some people who would like to go, and there may be some opportunities to go as well, but life is not going to be that easy. And when it comes to survival, water is very, very important. Food is very, very important. And how do we spend our time is also very, very important. Some kinds of psychological things, isolation and other things also very, very important.
Is there any HO2?
Yes.
A moon had HO2?
No H2. H2.
So how are we going to be?
We need to create that one there.
Okay.
We need to get an oxygen molecule somehow. We need to get a hydrogen molecule somehow and mix them. We do those things on the space station right now. We actually have on the space station a machine that actually picks up all those things and creates the water as well. And then from water, we also dissociate those things and provide oxygen for people as well.
Good. I'm the first one to go.
You are the
know
right.
why?
Oh, yes.
It's a joke, you know. If I go over there, nobody's there. I'm gonna own the whole land.
Oh my goodness.
And
That's
then
you
we
will-
build up society. I'm gonna be king down there, but the whole land, you know. Then when he come, I'll sell it to him. When you come, I'm gonna sell it to you. It's a joke.
Of course, of course.
What I was going to say that always fascinated me about the movie The Martian when Matt Damon
Yes.
actually yeah, I know he stayed, but when he was able to bring plant life or make potatoes, I know he was eating potatoes for like 20 days or 30 days or whatever it was. Been a while since I've seen the movie, but I mean, I thought it was fascinating that he was even able to set up a place on I think it was Mars. I think it was Mars. Mars to even get those plants to even grow in that soil. So I don't know if there's any scientific connection to how that process worked.
Well, actually, we're trying to do that one.
You're trying now.
On the space station, even before our own space station, we had the Mir station, the Russian Mir station.
Mm-hmm.
And then we had one of our own astronaut by name Shannon Lucid. She was on that one the longest time, for 6 months.
Mm-hmm.
She was actually able to grow seeds there on the space station with the soil that we took from here, with the water and other things that we provided there. And then from there, we got seeds from that one. And those seeds are going on. And we brought some of those seeds back to Earth and see how it is going to produce over time period. We're trying to do that one.
Right.
Even on the space station, they do that kind of research now. On the ground, we do research of simulated soil that we have and all those things as well. On the Mars thing, the problem is it takes about 1,000 days or 3 years for people to go and come back. You cannot just go and turn around and come back. You can go there in about 9 months, 8 months time frame. A spacecraft can arrive to Mars there, but you cannot just turn around and come back, because you'll never come back. Earth is going around the sun, and Mars is going around the sun. Mars takes 2 years, Earth takes 1 year. In some parts of the time, you are away. It takes difficulty coming back. So you wait on the Mars until there is an opportune time to come back. So it's going to be about 3 years time period. That's a long term for any food products to be transferred and delivered and all those things. Moon, it only takes about 3 days to get to Moon. And then you can come back from Moon in 3 days.
Well, 6 days.
And you can stay, longest people have stayed in Apollo missions, they have stayed there, and they can come back. We can work out those details. And today, one of the fascinating programs for NASA is to have a space station very close to Moon. It's called Gateway. From there, we can go to Moon and then come back. And then that gateway may not need that much energy, because we have a point there where it can be between Earth and Moon. The gravitational force is equal, we can leave it there.
Wow.
So we're working on that one, and Amy works on those things. That's the fascinating part. You can ask questions the next time when I see Amy.
I love to have her on the show. My other question to you, since you're a scientist, let us know. I mean, there's a movie made on that too, so I'm not sure how true is that. I
Gravity?
think Mel Gibson make that when you go to the outer space, your age is stopped. Is that true?
Oh, are you talking about Forever Young?
Yes.
Yeah.
Is that-
when he was frozen.
Yeah.
Yeah.
And that's the problem. But again, I heard that when you go to the space and you stay down there, that your age gets stopped. You're not getting older. Is that something true fact, or it's just a fascinating?
Oh, that's a fascinating thing, and it's a fact based on what Albert Einstein said in 1905. Albert Einstein came with these wonderful theories, and one theory is the theory of relativity. And in that theory, he talks about going at the highest speed possible. If you go at the highest speed ever possible, speed of light, everything becomes zero. The mass becomes zero. But if you go fastest speed, relatively, things are going to be different. That is called the theory of relativity. Theory of relativity. So people on the ground will be aging at their pace. People who are traveling at a higher speed will be aging in a different rate. So if you are traveling too fast and going further and coming back, your age may be less. That is called the theory of relativity there. That is a theory in 1905. He was not given Nobel Prize for that one, because it's more complex in those days, even now, let alone those days there. But he was given Nobel Prize for something else. He predicted that is a photoelectric effect, which means when light hits on certain material, electrons, even though they were not identified as electrons at the time, electricity can be produced. And that is called the photoelectric effect. We have these solar panels on these things nowadays. It took almost 70, 80 years to develop them. And 100 years later, human beings are keeping on their rooftops there, the photoelectric effect there. He was given Nobel Prize on that one. But this is one of the theories of Albert Einstein. Of the three major aspects of that one is the theory of relativity. And that's where we talk about those things. It is possible. But how to keep the human life alive at those speeds is still a challenge. At the most now we can go probably 1/100th of that speed. Even then, some people cannot take it. They have to have a special suit on these jet aircrafts for warplanes and things like that. That is still 1/100th of the speed. But you got to push to that limit. How human beings will survive, we don't know yet. It may not be possible for human beings, because human beings in low gravity in space station, for example, their heart is not good enough to pump the blood towards the feet all the way down. On the ground, gravity helps a little bit. You're going into zero gravity, microgravity, and that's why their upper body looks swollen, and their feet and the bones will go a little bit deteriorated. If they stayed for 6 months, 1 year, one person stayed there, coming back, It's not easy just to walk around. Even after 14, 15 years of flight, sometimes landing back in Houston like Jude just did, you will feel a little bit different.
A little jet lag. Yeah.
So now we're talking about gravity.
Right.
No gravity. It's going to be different there. So that's what is the important thing here. How best we can keep the human being still alive at low gravity for long periods is a challenge. On the same note, how we can keep this human being alive at high speeds is still unknown.
Wow.
The pressures are so much on the human body there.
Well, that's what that's the Air Force, that does, because you have to have a very, very high efficient your body that can tolerate. Because
Exactly.
Because when they
And
do,
then they have the body suit too.
Yes, they do, and
Keep
even
that.
their body suit. Sometimes you see it, the blood will come off their face and everything up. It's a very, very tough one.
It is a tough one.
Yeah.
It's a tough one. That's why we chose younger people, stronger people to do all those.
No, that's
things.
true. You're right.
Sure,
That's
sure.
true. That's why they have to be certain weight.
People
and
who are
certain
more
height,
fit. To endure that type of exposure.
Exactly.
Yes.
So now I got all those things here, and let me bring back my screen back to the evening sky. What we have here. So I think it looks like I need to change these things here a little bit here. I'm going to pause on this one a little bit, and except for one fact that I want to show you before I take away the screen here, and that is going to be, I want you to see and appreciate this particular pattern of the sky in the evening sky, and that is called the Bellatrix, and this is called the Betelgeuse, and this is the Rigel, and we have 4 stars there, and we got 3 stars in between. How did people communicate about these star patterns in the sky in the past is a fascinating thing for me. They don't know how to tell from Mr. A in one country to Mr. B in a different country that they're looking at this part of the sky. So they came with this fascinating approach there. So they started drawing the lines between those things there, and that's how it looks like. If you can draw the lines there, you are trying to see something now happening there. And it looks like a fascinating one. Somebody came with this idea, maybe these lines can make a pictorial depiction there. So my youngest son was, we always say that he was going to college at the age of 7 years, because he was taking these art classes at the age of 7 years in a Lone Star college. So we call it, you go to college at 7 years, okay? And then that is only for elementary school kids there. And he will come back home and say, Dad, draw me some lines. I'll do some lines, random lines. And he will create a beautiful picture of that one.
Mm-hmm.
That's what is going to happen. In these lines, if you can try to imagine a pictorial depiction there, look at that one now. So those are the same stars and those are the same lines, but they made a human being out of that one, and they named that human being as Orion, the constellation here. And the story is, this is the hunting season, right, Mark? And the people actually go and hunt these days. During this hunting season, this appears in the evening sky there. And this is the hunter there, Orion the hunter, that's what the name gave. Look at this one. There are other stars also which we don't see. When you combine all those things, it looks like he hunted an animal there, and he is kneeling down on his right knee. We got one name of the star here. On the left heel, the name of the star is the Rigel there, and the Betelgeuse and other things. We don't have internet, we don't have mail system, we don't have anything else to communicate from one part of the world to other part of the world. But this is how best they could have communicated those days to know this is the Orion, the constellation here. And these things, I will tell you, in terms of the distances here, look at this one. Betelgeuse is going to be, if you look at the distance here on this description here, 497 light years. If you travel at the speed of light, for 60 minutes you get somewhere.
Mm-hmm.
If you travel like that one for 8 minutes, light from sun to earth takes about 8 minutes and 20 seconds. I told you 93 million miles, right? About 150 million kilometers. Light travels at 3 times 10 to the power of 8 kilometers per second, which means there are 8 zeros there. 150 million here. When we divide by that one, we get the number of seconds, 500 seconds there. 500 seconds is nothing but 8 minutes and 20 seconds there. That's how it takes the time for, we're coming there. Good question from Bessie. We're going to answer that one in a minute there. So now, it takes 8 minutes and 20 seconds from sun to earth. From earth to moon, it takes 1.25 seconds. 1 point some seconds, that's it. Because it's only so close for us. 360,000 kilometers, whereas this one is 150 million kilometers. That's why when we talk with the astronauts on the surface of the moon, we have to have that gap. We say a sentence we call Roger. That means I will stop talking, you respond back. And they will say, Houston, we have a problem. Roger, we'll understand.
Famous words.
Those are the words that we have in this. And I think Duke will agree with me. About 20, 30 years ago, when we call back home, there is echo. We got to say the word and wait. And then wait what they're saying here and then respond back. Same thing even from California to Houston, we used to have an echo there. Because the time delay in these satellites. We don't have so many satellites in those days. So they got to wait, package, and send to other satellite to communicate back. Now we have hundreds of satellites, thousands of satellites, and the echo is almost negligible there. We want instant response as well. And that's why these text messages and so on. So here is the question here. If this is Orion, he looks like he's having a belt here. That's what Betsy was suggesting here. Orion, the belt. And this is the belt that one. Let me check about 3 different stars on this belt here. I mentioned about 450, 497 light years, right? Look at this belt. This star is going to be 817 light years. My goodness, is even further deeper there. If you take 497 years to get to one star, you got to travel another 400 some years to get to that. We don't live that long. If somebody is living, we'll send them there. And then look at this one. This is going to be 1,976 light years there. The third one is 960 light years. So we're talking about 1,000 light years, 1,000 light years, and 2,000 light years away. 3 different depths there. But appears as if they're all on the same line. And they are the same line appearing all these centuries there. Maybe if you wait for 400, 500 more years, slightly changes. We're not going to live that long. They may. But we are not, right? Okay. Let us look at this one, Rigel star. Rigel star is about, you can actually see this one on this 862 light years there. And so far away and so on. All those things here. Let me give you the last glimpse of this one. We're talking about one constellation. There are hundreds and hundreds of constellations there that people came with the names. And then, in fact, there are not hundreds of them, about 30 plus of them. And then some of those things are known as 12 for the zodiac signs that we use, that we can actually see on our path going around the sun. And then each month we see a different one entering and all those things. There's 12 are part of these 36 or so of these things here that we don't see or we don't care for all the time here. These constellations are good for the northern American side where we are in Houston. We can see that one above us. But if you go to Australia, you get a different set of constellations there. They are beneath the equator and so on. All those things there. So these are the names that they have on all those various items there, and Libra and all those things. You can actually see Ursa Major and Ursa Minor and all those things. And that's how I would like to leave this part of the software for us and then go back to our regular mode. And now I don't know where we are. We moved a lot around, and then we will take out all these things here, and then we will come back to, that is the western part of the sky, and that is going to be our northwest part of the sky, and I'm coming back to north side, and then we are going back to northeast, and this one, the last one, that is the eastern part of the sky, where our moon is going to appear about 12 o'clock midnight, and then we will come back here to the western part of the sky where our sun is about to set, and I'm going to set the time for you, and that is the western part of the sky here. And then let me see if I can bring back my timing here now. Let me see. I don't want anything in the screen here. That's very good. And this is like 1 o'clock in the middle of the night here, and I'm going to go back here. We will come back to that is about right now about 6 o'clock, and that's what we have here.
It's mind-boggling.
It is.
That is 7 o'clock in the evening, and we'll come back to 6 o'clock in the evening. Right now, you still have the sun outside. If you don't believe Adam, we are here. The sun is still there, and this is the time we have right now on this particular software. Any other questions for me, or else I can go to the next part of the episode that we can discuss tonight.
Okay.
Do you all have energy? You all look very happy now, as of now.
Yes, it's up to you.
Yeah.
Okay.
We're
So
good.
what I will do is I will pause on this one. I will go to another presentation. In that presentation, I put all the material as slides for us, and then we'll go through that one, and Adam will do his magic to bring that one there for us in the final episode there, and we'll do that one. So let me quit this one very quickly, and we will use this one as we go by in the days to come. And I have a lot of these things prepared for us. And yes, go ahead.
Dr. Prem,
Yes, sir.
how long this going to be taking?
This one probably, I will do this one in about, let us say, less than 15 minutes.
Okay, that's fine.
Okay? After 15 minutes, we'll think about it and we'll decide what we want to do, and that will give enough material for.
Yeah, I mean, 15 minutes fine. Then we can come back to the next episode,
Sure.
next week or
We'll do that.
whenever. So that way
Whatever, yeah.
we can have the sequence coming up.
Exactly. So that is a fascinating one, and thank you, Duke, for that wonderful thought. We have only a kind of overview and appetite for us tonight, and then we will continue these episodes. And I plan in such a way we want to talk about more about the universe, all the galaxies and other things that we see, and then about our own solar system got its own mysteries, and then finally we want to come to Earth. So about 3 major parts, and each part may take about 3 episodes. So we're talking about, you need to sign up for a long time to sit here and listen to me.
Okay.
I got 1 glass of water, so until it is done, we'll be talking about this one.
Yeah, we will plan that thing up. We'll set it up the timing and we'll make that our episode. How we're gonna be doing. Today, I call that is like a pilot program.
Sure.
We start the pilot program today to see how everything goes, and then as we move forward, we'll polish it up and make it more and more into, and then it will be positive. That everybody can have the same time watching same. That's what we're gonna make it up.
That's wonderful.
Thank you.
We'll do that one. And then let me see how best we can do here. Our perspectives of the universe. What we can imagine and what we can think and what we are thinking so far. And I just want to give you a few glimpses
Sure.
here. So in our own galaxy, we are a small dot. If you can imagine the galaxy box on the top left here, and nobody could take a picture like this one yet. Even though we have billions of iPhones, nobody has gone above the galaxy to look down yet. It's estimated to be about at least 200 plus years for our spacecraft to get there, to get a glimpse of that one. So we don't. So we take other galaxies and imagine that one. In that galaxy, somewhere here, away from the center, about 1/3 from outside, if you can imagine a small dot, that dot is going to be our sun. That sun, he got all our solar system here, all the planets we talked about so far are all there. That's about it. And then we have the nearest stars here, Alpha Centauri and other things here, and the Sirius star, which is going to appear in the evening sky for us, and so on. And this one we estimate about 10 light years cube here. It takes about 10 light years, okay? Not in our lifetime. 10 light years. Light traveling at the speed of light for 1 complete year is called 1 light year. Not just 8 minutes from sun to earth, but 1 hour, 24 hours, 365 days. We're going to cross our solar system hundreds of times by this time. And that's what you see. We got 10 light years, that's the cube that we're talking. This is the Orion Nebula here. Not too far away from us, we can see this one. And then we got, this is where we have the Orion Constellation and so on, other nebulas. So we're going to see some of those pictures as we go by here. Just our own solar system, let us look at this one. I'm always fascinated with the dimensions of these objects in space there. The extreme left four, Mercury, Venus, Earth, and Mars, very close to the Sun, are known as the terrestrial planets with a solid material. And then we have Jupiter, Saturn, Uranus, and Neptune. They're all light gas giants there. The largest one being Jupiter, and the next one is being the Saturn there. If you include the rings also, it's going to be even larger than that one, and that's what we have here. Look at this. Mars is half the dimension of the Earth. Venus is as big as the Earth, and Mercury is tiny, little bit bigger than our own moon, and that's what we have here. And these things are very, very big and so on. So when we move on to the next one here, I want to just give a glimpse here. Now we are taking the pictures of these objects and putting there. This is the family portrait. Sun is behind. They're so big. And then you got Jupiter looking a little bit bigger. Saturn is here. And then you got all these things here. Look at this one. These tiny things. Our Earth is this one, number 3 from the left-hand side. Venus is number 2 on left-hand side. Mars, you want to go to Mars and live there. It's so small and tiny. Duke wanted to buy the entire moon there. That is a dot there. You hold these things in your mind. On the right-hand side, I have a few snippets here. These are the dwarf planets. We put our Pluto also in that category.
Yeah, I was about to say, where did Pluto go?
Pluto is in that planet there. We got other things there. Those do not follow the expected rules and regulations. We put them there as dwarf planets. Maybe they will be planets, they will hold on for a while and they will disappear and so on. Look at now, we'll just face our eyes towards the Sun and see what is happening in the Sun. A small picture of the Sun, look at this one. That is the Sun. Sun is peeling off these energy particles there over the years. Every 11 years it will be very, very active. We're actually getting to that active time right now. 2024, 2025 will be very, very active there. If those things start popping out and some of them come towards the Earth, and if they affect our satellites, that's the end of the story for our communication for a while.
Yeah.
Nobody can hack the Facebook at the time for a while.
Is that like a lava coming out, or?
Exactly. Imagine the lava part.
Yeah.
Here we call
Like
it
a fire gas. Or
coronal mass ejection, CME. This is going to be a peel of that one. You want to imagine this big. How big is this one? We can see this one from our spacecraft called SOHO spacecraft. It's been there for 20 years now, watching at the Sun day and night and providing immense material. And we have another thing called Sirius telescopes, 2 of them going in the orbit around the Earth, around the Sun, looking at the Sun from different directions there. And we have other things we'll talk about in different areas there. I want to bring the dimension of the Earth and put it here and imagine that is your Earth there. Your Earth is like a small dot compared to the peel of the energy that is coming out. If that comes and hits this one,
it
Duke
becomes
is worried
a form of
about
a fireball.
all these volcanic things in Hawaii. A small dot of the island compared to the big ocean there, so far away, is covered the whole thing. Now this can cover the entire Earth.
It is, I mean,
Not just the entire Earth, many times over the Earth. And that's how big this. But the good thing is, when it is happening on the left side of the Sun, when we see the Sun, they are not going to come towards us. If they do happen on the right side of the Sun, on the small sliver, they will be connected to the Earth magnetically, and they will come towards us. So we watch all these things. Left side, no problem. Some more days, it takes about 28 days to go around. 7 days, oh, it's still active. Maybe we need to be watching in the middle of the Sun. It may travel towards the right, and all those things will watch.
So you think so that will come down some point?
These things, when they peel off, it goes into the space.
Okay.
And it may not come towards the Earth is here. We are looking at the Earth right now. It goes away from the Earth.
And it's still in the floating.
It's going to disintegrate into many particles. It's going to go and hit other things. If there's Mars on that side, it will go there. In fact, it did. In 2001, one such activity, not towards the Earth, but it went towards the Mars, and on Mars we have instruments on our spacecraft there, and they actually measured, and the instrument also got affected by these particles there. So we know this is the real thing here. Now let us come back to the Earth here. On the Earth, Moon is such a big thing. Joke, that's all you got there. You think you got more land on the Moon? That's all you got. 1/6 the diameter. 1/6 the dimension of the size of the Earth is the moon there, a small tiny part there. Now I will take moon and Earth and compare with other things we have here. You see the Venus is on the right hand side, Earth is on the left hand side, almost as big as the Earth here. Mars is half the size of the Earth. Mercury is tiny, and Pluto is even tinier there.
Yeah.
So we got so many planets now, and we're going to add some more here. Now you got you can't even see moon anymore except the dot next to the Earth there, and that is here. And you got your Venus here, you got Mars here, you got your Mercury here, and you got Uranus, Neptune, Jupiter. Look at that one, how big is that one? And Saturn.
Jupiter is gorgeous.
Jupiter is gorgeous, and you want to go there, and you go there, it will attract you and it will pull you in. You will never be able to move.
That's true.
So those are the
It's
fascinating.
too magnetic. Yeah.
Exactly. That's right. Exactly. And we even avoided going closer to the Jupiter when we were sending in 1972-74 the Voyager spacecraft as far away as possible, so that our electronics will not be affected by the radiation, other magnetic fields there. And now we figure out a different way to get there on a Juno spacecraft and so on. So this is a fascinating one. Now let us pull all these things back and then compare with Sun here. That's how Sun is going to be. That's so big. How do you explain to a small child how big Sun is? One astronaut came with this great answer. I love this one. You buy a cookie for $1, the big size cookie. You eat entire cookie. The crumbs left over on your fingertips are like the planets. That is just an illustration. And look at this image here, drawn to the scale here. That looks like a big size orange there. And all these things are small, tiny dots. And even Earth is such a dot, 1 pixel. And we're going to go to the next one here. And now, even Jupiter looks like a small one. Your Sun is still a small one. Sirius, Pollux, and Arcturus, all those stars that we know are not too far from us in our galaxy, so to speak. They are much, much bigger there. So don't feel proud about your own Sun now.
The 3 times bigger than.
Where is the Sun here?
Way down there. Or,
All the way down. This is the entire solar system, including your Sun. That is a dot there.
yeah, that's the Sun.
And I'll go back one more time here. And this Arcturus and Pollux, look at that one. They are becoming small things here. The Sirius is going to be the blue color one, and that's what here. Now we got Rigel. Remember Rigel star and the Betelgeuse star that I showed you in other constellation? On 2 ends of this Orion belt, they are bigger, much, much bigger, millions of times bigger than our own Sun, so to speak. So no wonder they are so far away, 400 light years, 800 light years away, and still considered to be small dots in the sky for us.
Right.
Because they are so far away and so on.
That's the beauty of it.
That's the beauty of that one. So here is my final thought for you. This, because I said 15 minutes, I'm going to stop now, and hopefully this will be a good point for us. I'm reading from the scripture Isaiah 40:26 here. Lift up your eyes and look to the heavens. Who created all these? He who brings out the starry host one by one and calls forth each of them by name. Because of his great power and mighty strength, not one of them is missing. All these words mean so much. If anything is missing, things will not be in the proper way. We may not need to be ready to go to work tomorrow if anything is missing. They are very, very important. They are so far away, even the moon in its orbit, Earth in its orbit, they will not miss. Lift up your eyes and look to the heavens who created all these. That's the question. He who brings out the starry host one by one and calls forth each of them by name. We are having difficulty for 7.6 billion people in the world. I think there are many Mikes in America, many Jose's in other parts of the world, and from India there are more Patels all around. We name the same thing, but here it says each one of them by name. He got the names. We don't know. because of his great power and mighty strength, not one of them is missing.
Yes.
I will stop at that point, and then we'll catch up next time on the next episode.
That's good. Before you say one thing, I'm at my last question. When that sun, that thing was peeling away, any kind of register at that, what the temperature on that?
Actually, we know.
You do?
We know. On this one, this is a question from you. Yes. We know the temperature on the sun.
Uh-huh.
It's going to be a huge number, 24,000 degrees Kelvin and so on. These things to happen, the magnetic fields are going to pull together. People used to call them sunspots on the sun. When these sunspots are spread out, not much is happening. For the equator, when they are coming closer every 11 years, when they collapse, different directions of orientation, they pull them together.
They merge
The
together.
temperature is going to increase so much. Sometimes the back part of the temperature is so low, they are going to separate themselves. That part is happening there. People have studied these things by looking at the light and the brightness of these things. They can estimate the temperature of these things happening. It is a very hot lava, and I will say 1,000,000 times hotter than the lava that flows from the ocean to the sea side of the Hawaii. That's very, very hot. We cannot sustain anything there. No instruments can survive there. There is a new spacecraft called Parker Solar Probe. It is actually making rounds around the sun, getting closer and closer. Left from the Earth, now as close as the Mercury and Venus orbits there now, and it is getting closer and closer. The idea is to actually measure these things, the temperature and other things.
Is that your one capture?
That's not, we will work on that. We get the data from that one.
Okay. Good, good. All right.
It was amazing.
Thank you very much,
You're welcome, Dr. Prime,
Mark.
and my good friend, and Mark, thank you very much.
Absolutely.
It's very educated, and we are looking forward to have more episodes.
We definitely look forward to, and though we have people here sitting and doing all the work behind the scenes, like Adam and Betsy and Duke's sister here, we recognize them too.
Good,
They are
good.
part of this excitement to bring these things for all of you.
Absolutely.
All right. Thank you, Dr. Prime.
Thank you very much.
Very much, And thank you, Mark,
Appreciate it.
I think, come on, have a seat, and looking forward to have some more episodes with you. And it's going to be very educated. And you can chime us with the Facebook and our other site, YouTube channel, everything up. And this episode, I'm hoping probably the next week we'll have it in the channel after we do that. And good night, have a peace. Thank you very much.
Thank you.